So let us rejoin and start with the topic with which left with the electrode potential. Now I am making these videos for my students at PICT at my home during this quarantine situation, and I am making it on mobile, and to upload the larger size video takes a lot of time, so I am making one video of 15 to 20 minutes. Okay, anyway, this electrode potential. Let us see situation. We have mentioned that metal shows a tendency to pass in the solution as metal ions. Okay, so when you immerse a metal in water or in a solution, some of the metal atoms will shed their electrons and metal ions will go in the solution, isn't it? So somewhere negative charge electrons will remain held to the metal ions, rod, and it result in the formation of electrical double layer. Okay, and all metal ions will pass in the solution like this, in the solution, and there develops a potential between the solution and the electrode, right? So that explanation is given by Nernst theory. One line idea we have mentioned that when a metal is exposed to wet condition, is exposed to some conducting solution, it is passing in the solution by losing electrons and by forming metal cations. This tendency is expressed in the term or with this name that is called as electrode potential. Under standard condition, that is called as standard electrode potential, isn't it? Now how it is recorded means, what is that? We have given the example at what rate the element or the metal shows tendency to undergo oxidation, at a faster rate, at a moderate rate, at a low rate, or instead of undergoing oxidation, that is a loss, that is a corrosion, it may undergo reduction, that is gain of electron. That also we want to record, whether it will work as a anode part or cathode part, whether it will undergo oxidation or reduction reaction. That is measured in terms of electrode potential. That explanation is given by Nernst theory, isn't it? Nernst theory. Now we are not going in detail of Nernst theory because that may not be part of discussion. But how to measure that? What information you are getting from the electrode potential values of different elements? How they behave when they form a cell, Corrosion cell, electrochemical cell, which part will work as anode, which part will work as cathode. That information will be getting from electrode potential value. If I want to measure electrode potential of this element, suppose element A, right? How it can be measured? Let us take case that I am an element, I am a metal, and I want to measure my potential, right? Let us take, it is a physical potential. In my case, it is physical potential. How it has to be measured? In that case, I have to see my strength, to record my physical potential. I have to play boxing with somebody else, and it is not somebody else, it should be a standard, because I want to measure with anyone. I cannot box, I have to box with some standard material, isn't it? With a standard element. A standard electrode means it is called as a reference electrode. What is the role of reference electrode? It is just to complete the half cell reaction. Means if I am giving punches, it will take the punches and it will record how many punches are given. And if I am not giving punches, it will record what is my capacity to take punches. Giving punches oxidation, taking punches is reduction. This way it has to record. Means to record my physical potential, to find out my physical potential, to measure it, I have to fight with a standard material. I have to couple with a standard electrode, and that electrode is called as reference electrode. That electrode is called as reference electrode. It may be standard hydrogen electrode or it may be gallium electrode. So these two electrode has to brought in a contact, and they should be exposed to the corresponding salt solution or the aqueous solution, isn't it? If this is copper, So it will be copper sulfate. If this is zinc, it will be zinc sulfate. And like this, they should have electrical contact, and somewhere here we'll put a voltmeter, and it will record whether deflection is going here or here and what is the value. So simple point is that to record electrode potential of any element, any metal, it has to be coupled with a standard electrode that is called as reference electrode, and it is either SHE and calomel. Mostly it is measured in volts and mostly at 25 degree centigrade, isn't it? Right? Now once again we know electrode potential, tendency of metal to pass in the solution, tendency of metal to go in the solution by giving electrons, by forming ions, is given by electrode potential. So greater the tendency of metal to pass in the solution by forming ions, by losing electrons, greater number of ions get formed. Greater the tendency of metal to undergo this reaction, greater number of ions get formed and greater number of electrons get released. And greater the number of electrons get released, more negative will be the value of standard electrode potential, and more negative the value of standard electrode potential, more is this tendency, more is this deterioration tendency, or more will be the tendency of metal to work as a anode part of the cell. So it will undergo oxidation reaction at a faster rate. This is what information, this is what is the information we are getting from the electrode potential values of different metals, the different elements. Once again I repeat, the tendency of metal to go in the solution by forming ions, metal ions, by losing electrons when it is dipped in the conducting solution, is measured in terms of electrode potential. More the tendency of metal to undergo this kind of reaction, more number of ions get released, more number of electrons get lost or formed, more the number of electrons form in the reaction, more negative will be the value of standard electrode potential, and more negative the value of standard electrode potential, more is the tendency of metal to work as a anode part of the cell. And we know that anode part always put to loss. Anode part who undergo oxidation always undergo decay and deterioration, always undergo decay and destruction, dissolution, isn't it? So that information we are getting from the electrode potential value. So workers, means scientists, they have recorded electrode potential, standard electrode potential of almost all the elements, and they have arranged these elements as per the electrode potential value, as per their increasing value of electrode potential in different series. Okay, what are these series? Let us know that. Again I repeat, scientists has recorded electrode potential value of almost all the elements, and they have arranged them in a series. In a first series, it is called as electrochemical series. Electrochemical series. Okay, as per the increasing value, as per the increasing value of ACP, these elements are arranged, isn't it? Now in getting it, so first series in which elements are arranged as per the increasing value of their standard electrode potential. Okay, that series is called as electrochemical series. What is the meaning of that? Meaning is that first element in the series will be having maximum negative value of SEP, that has given first position. In my PPT, I have given the list of, I think, 20 elements, commonly used 20 elements in different structures, and how they are placed, their values, that part is given. Hurriedly we'll see the ideas. What is the second element? It will be comparatively less negative value. okay, of standard electrode potential. Third position will be taken by still less value, still less negative value, and then it is still less. This will be minimum negative value. Suppose it is the element number 20, right? Element number 20 maybe like this, and so on. Below that it will be 21 is SHE, which has zero value of, which is standard. This is a reference. This is a reference electrode. Getting it? Its value is 0. And 22nd may be minimum positive value of SEP. Then 23rd may be some higher positive value of standard electrode potential. Then higher, and finally it highest. That may be highest, isn't it? This way the elements are arranged. We may require this series to answer few questions or to collect some information. You may not require to recall or memorize the values. What is the exact value in volts at 25 degrees centigrade? That value may not be required, but sequence of at least 20 to 25 elements, few above SHE, few below SHE should be known to us. So this is rough information, but correct information. Elements, metals are arranged in this manner in the electrochemical series. Okay, maximum negative, less negative, down there minimum negative, SHE, zero value of SEP, standard reference, then minimum positive, high positive, more positive, and highest positive. Okay, this way. Now what? So one question may be asked: what type of information we are getting from the electrochemical series? The information is all the elements who shows negative value of standard electrode potential prefer to work as anode part of the cell, always undergo oxidation reaction, corrosion reaction. First information is that all the elements who are placed above reference having some negative value of SEP, standard electrode potential, will prefer to work as anode part because they have a tendency to lose electron. All the elements who are placed below SHE, below the reference, having increasing positive value, some positive value of SEP, prefer to work as cathode part of the cell, and cathode part never put to loss. They always undergo reduction. Okay, gain of electron, coming to the classroom is gain of electron. One who is sitting in the classroom never put to loss. One is going out of the classroom may put to loss. Roughly like this, isn't it? So this is the first information. Second, suppose in a galvanic couple, element number 1 is there, okay, and element number 5 is there, and they are exposed to the medium like this. They are in electrical contact. One situation is element number 1 and it is in contact with element number 8, and they are in electrical contact, they are exposed. Such situations are there. Or in two cells, one cell, second cell, element number first coupled with fifth, here first coupled with 8 element. In both the types, all 4 are having negative value, but when 2 negative elements come in electrical contact, exposed to medium, more negative element will work as anode part, lesser negative will work as cathode part. This will be again anode part, more negative value, less negative will be cathode part, right? And in which type corrosion reaction is more? This is type 1, this is type 2 cell. In the second cell, rate of corrosion will be more. More the difference in the anodic cathodic behavior. This will be strongly anodic, this will be strongly cathodic. They are like this. First case is like this, second case is like this. If they are away from each other, one will be strongly anodic, one will be strongly cathodic. This is the second information we are getting from the electrode potential values, isn't it? Electrochemical series. Third information, what information we get? All the elements who are placed above the reference in the electrochemical series, like all these negative elements, not electronegative, their electrode potential value negative, when they are exposed to acidic medium. When suppose Fe is exposed to acidic medium, yeah, all the elements who are placed above the SHE, like these elements, and exposed to acidic medium, they undergo corrosion. They are anodic, they undergo corrosion, but that will be observed by evolution of hydrogen gas. That will be observed by liberation of hydrogen gas. The one type of mechanism actually. Who shows that type of mechanism? All the elements who are placed above hydrogen, and when they are exposed to acidic medium, they will undergo corrosion, which will be observed by liberation of hydrogen gas. So their potential is more. They are having more potential than standard hydrogen electrode. So when they are exposed to acidic medium, there is a dissolution, there is a decay. Okay, but that they undergo decay. But during that process, they liberate hydrogen. They take out hydrogen from the medium. But these metals who are placed below hydrogen, their potential is positive. They are less. They are having actually less reactive. They are more noble than this SHE. When the same element like copper, like few more, all these platinum, palladium, they are exposed to acidic medium, they will not undergo corrosion by liberation of hydrogen. They are less active than hydrogen, we can say. They are more noble. This is the second information. Once again, what is second information? All the elements who are placed above hydrogen, having negative value of electrode potential, and they are exposed to acidic medium, they will undergo corrosion by liberation of hydrogen gas. At the same time, element placed below hydrogen in the series exposed to acidic medium will not undergo corrosion by evolution of hydrogen gas. They are more noble to hydrogen. Hydrogen will not attack on the metal. They are compared to inert, isn't it? This is second information. What is the third information? If you look at the series, you will find there are few elements like aluminum, like nickel, like cobalt, like chromium, isn't it? These are the elements. Titanium, isn't it? So these are 4-5 elements: aluminum, titanium, chromium, cobalt, nickel. If you look at the position of these elements, if you look at the place of these elements, isn't it? In the series, you will find they all are placed above hydrogen, above reference. They are anodic. Okay? But in actual practice, they shows very high resistance to corrosion. They shows very high resistance to corrosion. I think we have not seen corrosion of aluminum particles. We have not seen corrosion of chromium metal or maybe titanium metal, because they show active passive behavior. Active passive. They show active passive behavior. Means as per the series, they are active. Their value is negative. But in actual practice, they are positive. Like in the classroom, few students are always show they are very active. They are with me in the class. I also feel they are active, but in their mind something else goes, isn't it? They pretend as if they are active, but they are actually passive. So they show active passive behavior. One line answer is, as per the values of standard electrode potential of this element, they prefer to work as anode part. They should undergo corrosion, oxidation, but in actual practice, they resist corrosion to very high extent, isn't it? This chromium is there in the steel. Steel, how much it is? Hardly few percent. But still, articles are not undergoing, steel utensils are not undergoing corrosion. It is mainly because of some amount of chromium in that. We'll come to this point afterwards. So this is one information we are getting from the series. I think this is the fourth information, isn't it? So this is the point. Now there are some drawbacks to series. What are the drawbacks? First point is that when the metals are taken to record the electrode potential, there are some drawbacks of the series. What are these drawbacks? When the metals are taken for recording of electrode potential, they were in a new condition. They were in a pure form and in a new condition, isn't it? So that is not the practical condition. First point. Second, this potential is recorded at a standard value of temperature. In practice, that temperature morning hours it is different, afternoon hours is different, evening hour temperature is different, region to region temperature is different, season to season temperature is different. So this is also not standard condition. That is the second drawback. And third is that the electrolyte they have used, the salt solution they have used, the electrolyte, it was of known concentration. Known concentration of electrolyte was used, isn't it? That is also not the standard condition. So because of these three drawbacks, this series is replaced by some different series that is more practical, that is called as galvanic series, isn't it? That is called as galvanic series. So I hope you have understood the basic points. You may get a question, compare electrochemical series and galvanic series, or what is electro potential, what information you get from electro potential value, or the series. So this series is replaced by galvanic series. Galvanic series. One more drawback of electrochemical series. Was position was given to metals only. They did not consider alloys. So that is also the drawback. Now what is the galvanic series? Galvanic series, they have given position to metals. Metals as well as alloys. This drawback is removed. So all the drawbacks of electrochemical series is removed by galvanic series. Position is given to alloys also, okay, apart from metal. Second, instead of using a standard concentration of electrolyte, they use seawater. To record the electrode potential. That is taken as the electrolyte. Third, they have recorded electrode potential at different temperature, not only 25, varied temperature, different values of different temperature, and they have taken the average of that, and this is then prepared. Then almost same series, that is you can read it from the books or the notes. So you should know the sequence. At least 25 elements, their sequence should be known to you. Values may not be required. Okay, so that is what is a brief idea of electrode potential, what is galvanic series, electrochemical series, their comparison, their plus minus point information we are getting from electrochemical and galvanic series. Okay, thank you.